So what we're going to do today is we are going to solve by graphing using a TI calculator. Now these steps will work with a TI, not necessarily with another graphing calculator, but this process shouldn't be all that dissimilar. My first step is to turn it on. Very convenient to have it on. My next step, anytime I'm dealing with graphing, I want to work with these 5 buttons mostly. Obviously to input my function I'm going to have to be using some of these, but looking at the actual function is going to be these 5. So I hit my y equals and I make sure none of the plots are highlighted. Okay, if they're highlighted they look like this. You can highlight it by hitting up and enter. I can turn it off by hitting up and enter again. I want to put my equation into y1. It just means the first equation. These calculators are nice. They allow you to put in a lot of equations at once if you want to. Here's my equation, this negative 2.34. Anytime I see a decimal like that, I'm probably not going to use one of my other methods because they're just going to get pretty messy. So I'm going to hit negative, making sure that I use the negative sign, which is below the 3. 2.34. Then I hit the x, okay, which is the x, comma t, comma theta, comma n button. My squared button right here. Then I hit minus, or subtract I should say, which is next to the 6. Subtract 4, another x, plus 17. Now, next step, hit graph, see what it shows you. So I see that I can see my parabola and I can see where it crosses, but I see all these thick lines. That just means I'm zoomed really far out. I always recommend starting with hitting zoom and then standard. That's number 6. So you can either scroll down to 6 and hit enter or just hit 6. And here's my parabola. In the standard screen, I can't quite see the top, and it's always probably pretty good to see the top or bottom, which we call the vertex. And so I see that it's going to be above my screen, so I need to stretch my y's out to the high side. So now, instead of hitting zoom, I'm going to hit window. This is like your manual zoom button. I'm going to change my y maximum because I know I wanted to see further up on the screen. Right now the y max is 10, let's double it to 20 and hit graph. Alright, that looks perfect. One of the ways I know that I can see it all is because I can see both my x-intercepts, or all that I need to, both my x-intercepts and my vertex. That's your goal in zooming around. Now, to actually find what point that is and what point that is, we know we have two answers. Two answers because it's a quadratic. So I'm going to write x equals and x equals. My job is to tell the calculator how to find those. Well, the calculator needs to calculate, so I hit second trace. We want to find zeros. That's one of our synonyms for x-intercept or solution. I hit enter. The first question it asks me is left boundary. Now, when it's asking me about the boundaries, I'm only concerned with the x-axis. I don't care where something is on the y-axis. So I hit my left arrow until I am to the left of where I want to be. I see this blinking cursor, and I know that every point down here is to the left of this 0 right there. So I'm just going to start there, and I'm going to hit enter. Then it asks me for the right boundary. See how it put a little arrow and it said, that's your left boundary right there. Now I need to create a right boundary. So I hit the right arrow until this blinking cursor is somewhere to the right of that 0, but not past a second 0. Because if you try and have the calculator do both at once, it'll cause some errors. So you're going to hit enter again, and now it says guess. And we know we want it to guess. That's why we're using this. And so we say, hey, give me a guess. Tell me what it is. The first x-intercept is negative 3.6. 0.68. But for now, let's go to 2 decimals, but always read your instructions to see what you should actually do. Now we just have to repeat the process. Second trace, 0. Now I want a left boundary, but I want it for this 0 right here. So anywhere on this part, on this half of the parabola, is helpful. That is, this cursor right now, if I dropped it to the x-axis, would be to the left of that 0. Now I need to go to my right boundary. Now as long as I keep hitting the right, the cursor would actually kind of, in your imagination, be way down here. I can hit enter. It says guess. Yes, please guess. And my second 0 is 1.97. That is how you graph and solve by graphing using a TI calculator.